Alright guys, so once again, after all the theory, now let's have a practical view onto this topic. And let's do some exercises and practices a little bit, because otherwise it's really hard to grasp, right? Therefore, let's have a look. Here we are back at Ubuntu VM and I have prepared a really nice application for you. As always, you can download the whole source code as an attachment of this section, because we haven't taken a look into reverse engineering yet. The application is fitting into our alarm system topic, and even if we are missing, let's say, quite a few features, we've got a use case which I encountered in a real-world application. So this is something I really want to show you in this, let's say, mocking application. Alright, let's have a look. So I've already got the smartphone running. Let's enable it. Okay, and if we scroll up, we've got this amazing app, Alarmpin. So this time I have put some effort into the layout and I hope it looks okay. So never mind. I mean, this color scheme, yeah, let's go over this. So we've got a login and we've got a username and a password. So I will tell you what these features are. The username is admin and the password, it's a PIN. It consists of numbers and I guess the initial password is 1337. But if you click login, yes, okay, it's still working. I thought I have played around a little bit too much with this one, but yes, here we have it. So now, after logging in, I mean, we have to verify if every PIN can be accepted, because I have written this application. But let's say the user has a PIN and we need to know this PIN, then we get into the next activity, which is now some kind of profile activity. And here we can change the PIN. We can also see that we've got this admin field over here, this one. So from the first activity, there will be already data passed into this activity, the username. And this also happens once again if we're clicking on change PIN. If we click on change PIN, then we can see the username admin will be also passed to this application. And now we can change the PIN for this admin. For example, 1, 2, 3, 4. And if you click send, PIN updated successful. Is there a typo? No, okay. Perfect. So now if we close this application, get rid of this line, and if we are opening it once again, let's see if my programming skills are really that nice. Username, admin, password, 1337, login, PIN is incorrect. Perfect. So you can see this even survives a restart of this application. So we're having some file content over here. Okay, let's enter this PIN. And here we have now the next activity. Let's take a look into the source code, because there we will see how those information will be passed from one activity to the next one. One question for this one: is it an implicit or explicit intent? Absolutely correct, guys. It's of course an explicit intent, because we know which destination we want to call. In this case, it's the profile activity. And here, if we click change PIN, it's the change PIN activity. So we know the destination we want to call. Alrighty. So let's have a look into the source code. And as always, you can find the source code as an attachment of the section until we talk about reverse engineering. Then you do not have the convenient source code anymore, because then we need to do this by ourselves. Alrighty? You can of course also start doing it right now with the JDX GUI or the other tools that are mentioned in the reversing section. But for now, we haven't talked about this, so we stick to the convenient source code. Alright, let's open this one, not this one, this one. So the first view should be into the Android manifest XML, and here we have it. It's a little bit harder to read for me, but I guess we can still do this. You know what? Let's get out the graphic tablet and have a look into this one. Okay, so here we are back on the graphic tablet. Now let's have a look into this one. So let's see, how many activities do we have? We've got one over here. We've got one here, and this is another one. This one. Okay. We can see this one has an intent filter, and this intent filter is listening to the action main and has this category launcher, which means if we click on this icon on our smartphone, this intent will be sent. So this application is listening to our smartphone or into our smartphone and is waiting for this intent. So this is our message. intent. That appears when we click on when we click on our icon this way. Then we will start this activity. So this one is our first one. Okay. Let's get rid of my annoying drawings. And then we've got this user profile. There's nothing special about this one. It's not exported. It's simply just an activity showing our user profile. All right. Okay, so that was easy. But then we've got this one over here, the third one. And this one is exported true. And we also got an intent filter. So let's see. This intent filter is waiting for an action change pin. This is our action. And it also has this category default. This category default, I guess we have to look it up because I have already forgotten what this one does, but it's related to activities. So I guess if we want to start an activity, we need to have a category default to open it. Otherwise, if we trigger this action without having this category, the action or this intent will be sent, but the activity, this change pin activity, won't open on our smartphone. So if I remember correctly, this was the case regarding to this one. Therefore, with the category default, we also tell the smartphone, please open this change pin activity. And it's also exported explicit and over here implicit, which means we can trigger this from the outside world. This sounds absolutely amazing, right? Definitely. So we will have a look into this one. But first, let's start with the main activity and let's see what intents we've got in here. So therefore, let's switch back. Alrighty, so let's get rid. Yes, okay. So we start with the main activity. Oh, yes, I didn't expect that much content right now. So yeah, as already mentioned, this is not an app development course, but nevertheless, let's talk about a little bit of this, because the more you see, the more you get familiar with this stuff, okay? Okay, so the little bit version did extend into a 1 hour long video, and I guess no one wants to watch this if we want to talk about intent filters. Therefore, in case if you are interested in reverse engineering this line by line, then simply drop me a comment under this video over here and I will upload the extended version also as a video, okay? For now, we really focus only on the most important parts right now, but nevertheless, we take a little bit of a look around all these Android components, okay? So therefore, let's go. Over here, we've got simply 2 variables. There's nothing special about them. It's simply just 2 strings. Okay, and then we've got these edit text fields, those 2. And this is a little bit interesting within an Android application. I guess it's a good idea if we take the application on the right. There we have it. And now, edit text fields are things like this and this. So these are fields where we can put our text into. And those texts will be referenced by those 2 objects right now. So this one is our user. And this one over here is our pass. Okay. Then we've got the context. And the context, I mean, it took me weeks to understand the concept behind this. But the context is simply just the red dot on the map, which tells us you are here right now at the moment. So the context is telling the application you are right now in the main activity, because this information is required if we are interacting with other components. For example, services, broadcast receivers, or content provider. Or also if you're having some UI interactions, then we need to know where we want to put this UI, on which screen we are putting this right now. And this is the context. So the context is simply just the reference, we are here right now. Okay? All right. Next, we've got the shared preferences. In the shared preferences, I mean, this is it's a file, a text file, an XML file within the data directory. So our application has a protected directory within the data section. And within this directory, we can store files like the shared preferences. So this file will be protected. It's not possible to access this from another application. This one, for example, unless we are having higher privileges. Root or some system services are also able to access this file. So in case if we store some sensitive information, for example, user credentials, pins, password, things like this, I wouldn't count this as a vulnerability itself if we need higher privileges to have a look into this file. But in case if you're storing some generic values in there, then it's a different story. So let's say this file contains some default credentials, and these default credentials can be used to access other applications, so on different smartphones. This application, for example, this one over here, on another smartphone. Then I would count this as a vulnerability because this is an information an attacker has access to. All right? Okay. Then let's see. Then we've got the onCreate method, and the onCreate method, let's clean this up a little bit. The onCreate method is simply just creating the screen content, and this one over here. So everything that's placed over here is being defined in the onCreate method, because here we've got the layout and we are also assigning now this stuff. And here, for example, we are assigning the context, which is related now to the main activity. And over here we are assigning those two fields. So this one in user and this one into the password variable, or in this case, object. Okay, and then we've got an init pin method, but yeah, we do not take care about this one right now. Next, we've got the login function, this one, and now it's becoming interesting. The login function seems to be connected to this button. This means if you're pressing this button, this function will be triggered. And this is something we need to look up in the layout of this activity. So if you reverse engineer an application, we need to have a look into the activity main and layout, this one, which is located over here. And then we have to look for an onClick method, or within the Java code for an set onClick listener. If you find this login method in there, then we know if you press this button, this one, this method will be triggered. Okay, and this is a method we are going to analyze a little bit further right now. So let's clean this up. Okay, so here we can see we are fetching the username from our, this one is our edit text field, and this one also. And we're getting now those two into these two variables. Okay, user and pass. And now we make a comparison. If our username, this one over here, is equals admin, okay, and if our pin is equals the return value of this method. This method is being defined over here, and this method is simply just looking up the value which has been stored in the shared preferences file. So within the data directory, the protected directory. Okay, so within there will be our pin stored, and we are simply getting this information. In case if we haven't defined a pin right now, so if we have simply just installed this application and it's our first run, then we are assigning a default value, which is 1337. So this is our initial pin value. And we can see over here, if you want to modify this file, the shared preferences, we are using shared preferences.edit, the edit function. And then we are using put string to apply our data. And if you want to read from this file, we are simply doing it in this way over here. So here we can see why we are using the context, because the context is now defining we want to access this file, this one, from the main activity of our, what's the name? The alarm pin application. So that's the data storage of the alarm pin application. And by using context get shared preferences, this file knows, okay, we want to access this file from the main activity of our alarm pin application, and we are allowed to do this because this one over here, this is the protected data directory of the application itself. So this is why we can access it. And then we call get shared preferences, and we call this for the string pin. So the values in this file are being stored in an XML key value pair. So this one over here is our key, and this key has a value. In our case right now, the key is pin, and the value would be now, for example, 1337. Okay, so we assign this whole key value pair now to the shared preferences instance, and we can now access this field, this string, in the following way. We are calling in return shared preferences get string, and then we want to have the string of the key pin, which is 1337, or in case if no pin has been defined, default. So this is our default value over here, which means if no key has been found, then we are returning null. Okay, So that's the whole magic behind those shared preferences. Okay, but that's all right now regarding to Android app development, because we are interested in intents. But nevertheless, this is definitely something you should look for if you analyze an application. Alright, so let's clean the screen and now let's get back. So, if you're now providing the correct credentials, username admin and the correct PIN, in our case the default PIN is 1337. If the user hasn't changed this, we are entering this function. Otherwise, we are simply just printing out in text the PIN is incorrect. Okay, but now within this function we can see we've got this intent. And now it's getting interesting. So we can see we've got intent, new intent, and here we are defining now a new message object. So this message object will be sent from our this class, which is the main activity. So this is our main activity. And we are sending this right now, or we want to start the user profile class. So we want to start a new activity, which is the user profile. Okay, and this would be even enough. So this is our intent. And we could simply use start activity with our intent to trigger this. So our main activity would call the user profile. The main activity gets deleted from the stack and the user profile appears over here on the screen. But now we are also providing some information to our user profile activity. Let's see what are those information. Let's clean this up. Okay, the information we are providing are within intent, put extra. And we can see once again we're having this key value pair. So we've got this username, this is our key. And the username has the value admin. So these information are now being packed into our intent, and it will be also delivered to the user profile activity. So, sorry for this one. Okay, so here we are now having our intent, and this contains now our username. Username, which is admin. And this information will be now passed to the user profile activity. Okay? So let's see what the user profile activity is doing with this information. And therefore, let's clean this up. And let's have a look over here. Okay, within the user profile, maybe we should log in. And then we can see this. Okay, so here we have now the user profile. And this one, oops, there we go. This is our user profile. And here we can see right now in this line. So here we are fetching the intent. This was the message object from the main activity. We are fetching this intent, and we are initializing our own intent with the values from this one. So we're simply calling the method getIntent, and then we are assigning this intent over here. So now we have access to the information which has been provided in this intent. And those information were, let's see, over here we can see we are assigning now to our variable username the value from our intent. So we're using intent getString extra, this part, and we want to have the string from our key username. So within our intent we are having the information, maybe let's take in better color, let's say green. There we go. So over here we've got the information username, and the value is admin. So username is our key. Okay, barely readable, but I guess it's still good. So this is our key, and this one over here is our value. Okay, and we are now getting the value from our key username and assign this to this one. And then we can see we are calling TextViewSetText for our username, which is exactly what we are seeing over here. So this is now our username admin, which has been passed from the main activity to the user profile activity over here. All right? Okay, so this is how we can pass information from one activity to another. And also over here, we are doing it once again because we've got the method change settings. This one is being connected to this button. And here we can see we are now passing from our user profile activity another intent with some information to the next activity, which is the change pin class. Which information are we passing to this one? Let's have a look. Once again, let's clean this up a little bit. Okay. Here we've got our intent, and here we've got intent put extra. So we are putting some extra information into our intent. And once again, we are forwarding the username, which has been assigned over here, which comes from the main activity. So the username from the main activity will be passed to this user profile class. And from here, we are also passing it to the change pin class, this part over here. Okay, and then we're calling this start activity intent, which opens now, or deletes the user profile activity and opens the change pin activity. So this is also the reason why we see this username in our change pin activity. So let's clear this real quick. Okay, and let's see. If we click change pin, then we can see this admin field over here. And if we go into this class, let's see, there's a lot of stuff. Yes, so here we have now some interesting behavior. Okay. So first of all, we've got this intent over here. So once again, we are getting this intent, which comes from the user profile class right now. And we assign this to our username. So we once again fetch the value for the key username. This is our key. And we're fetching the value, which is admin. And we store this into a local variable username. Okay. And then over here, we've got the change pin method. And what this change pin method is doing is the following. It takes the text from the pin. So over here, we can see we're having edit text, get text to string. So we're getting whatever we have inserted over here into the variable pin. And then we are opening the shared preferences. So we're getting a reference to the shared preferences. And then we check if our username is equals null. If we do not provide a username, then let's see what happens. Only factory reset will be possible. So this means if we are not providing a username for this activity, the only thing we can do is the following. Here we are opening the shared preferences in an editor mode. And we are applying the default pin 1337 to our shared preferences file. And then we simply print out the message reset successful. So here we cannot define a new pin. We can simply just revert it back to the default pin. And this might be a pin that an attacker does not know. So it could be some kind of QR code printed on the back of the alarm system. The user has the information for this one, but not the attacker. This means an attacker, which is not providing a username to this one over here, cannot change the pin. The attacker can only do a factory reset for the pin, but this might not help further. So the attacker might not get an advantage out of this one because the attacker does not know the default pin. Alrighty? Okay. In case if we are providing a username to this one, then let's see. Once again, shared preferences editor, and then we are putting our pin, which has been fetched from this one over here. So from our edit text field, this is our pin right now. We are putting this into the shared preferences file, which is within the protected data directory. This is our new pin. And we have seen at the beginning of this application that this pin will be used to log into the application. So if we can provide a username to this file, then we can override the pin. It's now unclear if we have to provide a certain username because this is an else case, which means we could provide any username. It doesn't have to be null, but I mean, that's okay. If we are providing test, it should also work because there's only one pin available right now. Alrighty? Maybe not, but I guess let's try exploiting this right now. So maybe let's have a quick look into this function at the beginning, but I guess we didn't miss an important stuff. Yes, so here we can see we are just assigning those fields, an edit text, and text view, and a button. These are those fields. Let's see. This is our edit text. And this one is our text view. And this one is, last but not least, our button. This we already talked about this part, and here we can see, okay, if the username is not equals null, we set it to username. Otherwise, we disable this button. So this part would be disabled if the username is null. But I guess this is something we can easily try out right now. Okay? All right. And I guess that's all for this, for this functionality. Let's see. Yes, this is the part we have already talked about. Okay, so now I would suggest let's try exploiting this. So let's see how can we exploit this. If you take a look into the Android manifest XML, we have figured out that this change pin function is exported. Okay, so the thought process behind this of the developer might be the following. We've got our main activity, and from there, if we log in with the correct credentials, here we've got our username and PIN, we are opening the user profile activity, this one, and here we can now change the PIN, which opens the change PIN activity, this one. So if we have been logged into this application, we are having a user profile, which means here we are now having this username, in this case, for example, admin. And if we hit the change PIN button, then we are changing the password or the PIN for our user right now, the admin user. In case if the user has forgotten the PIN, this one has been exported, so it could be also triggered from another application, for example, an PIN reset application. So let's say here we are having our PIN reset app. This PIN reset app can open the exported activity, but the PIN reset might not be able to provide a username for this one, which means if no username has been provided, we can only reset the PIN to a default factory value, which is not known to this application or to an attacker right now. So this might be printed at the back of the alarm system. This might be the thought process behind this, but of course this is not true, because we as an attacker, we could simply, we could create our own application. This is our malicious application. And now we could also open this exported activity, but we can provide a username, which means we are not using the reset function anymore. We are using the change pin function for this username. So this was a real world example, which I have encountered exactly like this in a real world application. So this is something that can happen. Okay, so from the perspective of the developer, if we are not able to provide additional information based on an intent, yes, then this approach would work. Unfortunately, this is possible, and this is something we are going to exploit right now. So let's see how we can do this. Okay, to exploit this, we are using the activity manager, and we are simply triggering this intent. So the action change pin and the category default. So let's see, we are opening in terminal, and we're using the ADB shell. And now within the activity manager, we've got all the information we need. So we know how to start an activity, am start activity. And this time we do not necessarily need a component name. So we could provide a component name which is regarding to this activity, but we can also do this based on this intent filter. So this one over here, this would be an explicit intent, and this one over here would be an implicit intent. We do not know the destination, which application wants to open this, but in case if only one application has been registered to this event, then it will open. Okay? So let's do both. We start with an explicit intent, and we're calling the change pin functionality. So -n, then we need our package name, a slash, and then change pin. Okay, let's open the smartphone, and let's do this in 3, 2, 1. Unknown command start activity. Let's see. Yes, there is a typo. Okay. Now let's do this in 3, 2, 1. Okay, and here we can see if no user has been selected, the pin will be reset. So if we click reset, then the pin reset has been successful, and yes, once again we are having the 1337 pin. Let's verify this. Yes, okay, perfect, it works. So here we can see this is how we can reset the pin. And this one over here, it's an explicit intent because we have defined the exact destination we want to call. All right, now let's do this based on an implicit intent, which would be the following. So yes, let's make this a little bit smaller. We are now defining an intent, and we do not describe the application which is executing it. We are just describing the intent, which is this one over here. So this application is listening into the smartphone. Okay, I guess my ears are getting worse right now. It's listening to the smartphone and it's waiting for an action change pin. So this is a custom intent right now. We can see this based on the package name. That's not an Android specific one, it's a custom one. And beside this action, this intent also needs to have this category. Okay, so let's see how we can do this. Okay. So we are calling AM start activity, and this time we are using this information provided over here. So here we can see this is how we can define an action -a. Here we have this -d for data URI, and here we've got this -c for category. So if we want to trigger this intent, all we need to do is simply use AM start activity -a, and then let's copy this. And this change pin. And the category is over here. Okay, and now if we are opening our application, so let's close this maybe. Okay, so we are within the login right now. And now we trigger this implicit intent in 3, 2, 1. All right, same behavior, but different intent. In the first one, we have exactly defined which application or which activity we want to call. In this case right now, we have defined the intent, and this is the only application which is reacting to this one. So to this action com app hacking change pin with this category. I'm not sure if we require this category, to be honest, but I guess the activity won't be open. Let's see. Oh, it's still working, so we can see it's opening. It is enough to address this based on an action. Alrighty. So this is the difference between an explicit and an implicit intent. I have another example afterwards, but first let's exploit this right now. So how can we do this? In the change pin activity we have seen, we're using this intent get intent. And here we have seen we are fetching this key. So within our intent, we are fetching the key username and we are assigning the value to our variable, which will be checked in our code over here to provide this as a text, and also over here to make the decision if we are resetting this app, so the pin, or if we are simply taking this pin into our shared preferences. Okay? And this is a decision we can influence right now because we can define a username for this variable. This will be assigned over here. So all we need to do is we need to put this information into our intent and key username with a certain value. How can we do this? The answer is over here. So if we zoom out a little bit, here we can see we've got this extra key, and here we can see by applying --es or simply just e, we can define a new key and a new value. With EZ, we can define a new key and a Boolean value. EI gives key and integer value. So the last letter defines what type we are defining right now. In our case, our username is from type string, so we are simply defining a string value for this one. Okay, so let's see. Oops, did I change something? I hope not. Okay. Let's clear this, and now let's take the last command. Let's maybe opening the help here. Yes, okay. So with --es, we are now telling our intent, please pack some information into our intent, and we want to have a username Those quotes are not required, I guess, but I keep doing it, so please don't ask. Okay, so this is our key. And now let's say, for example, test. Okay, let's put the smartphone on the right and let's do this once again. Nice, we can see now the application has behaved differently. So it did react to our intent with our additional information. The test is being printed out over here. I mean, we're not having some kind of injection point, so that's not we cannot insert stuff like this, reflected cross-site scripting, because this is it's not a web browser. But I mean, yes, we might be able to use this for some kind of phishing. For example, your password has been hacked. Please change it over here. So then the user might define a new password, but I mean, we do not get an advantage out of this because the user is just defining a new password for its own application. But nevertheless, this is how we can interact with this application. In case if we are having multiple intents or not intents, values in our intent, let's see. Yes, if we are having some additional one, let's do it maybe this way. Pin. Then we simply can put them together. So over here we are having this username. Let me close this in the background. Oh, these are those processes. Okay, let's close this. Okay, so now we can read this a little bit easier. So here we're having the username and test, and then we could also do this, for example. Okay, so this is how we can apply multiple strings, integer values into our intent. In case if we're having an integer, we have to use it in the following way. Alrighty? Okay. So yeah, if we are providing additional intents which our application does not react to because this is not originally included, then it simply just gets ignored. Okay, now let's see if we can change the pin over here. So we have this test. Maybe let's name it hacked. Okay. And now let's see, we define a new pin, which is 14789. Send. Pin updated successful. Okay, looks good. Let's close this application. And let's reopen it. Okay, I mean the username is now still admin, it's not hacked. But let's see if we have overwritten the pin for this user. 14789. Yes, nice. So we have overwritten the pin for this user because there's only one pin entry available, therefore the username doesn't matter anymore. It's just required, if it's null then this won't work, but if we can apply any user value, then we are overriding the pin. Alrighty? Okay, amazing, right? So maybe let's have a quick look into this file. So within the ADD shell, root privileges, and then within data, com, app hacking, alarm pin. Intent sniffing is something we take a look into in a moment right now, so don't worry. Here we are now having the shared preferences, and here we are having our pin XML, and here we have it. Yes, we can see we have overwritten the pin. Alright, so that's the vulnerability in this application. And regarding to activities, I mean, it's not that it doesn't occur often anymore. It can still be possible, but it doesn't happen often. Regarding to broadcast receivers, this is a different story. So within broadcast receiver, this can still occur pretty often. This is something you should definitely check out, and this is also something we will discuss heavily in the broadcast receiver topic. Alrighty? Okay. One last example regarding to implicit intents, because I find this pretty ridiculous, sending out an intent without knowing which application reacts to this one. And let's assume we've got multiple applications. What happens then? Are opening all, or how is it being handled? This is something we are going to take a look into right now. And afterwards, within a new video, we are talking about intent sniffing. So therefore, we are still not done right now. Okay, so let's close this. Alright. We have already seen this implicit intent. So within the Android manifest XML, we have sent this intent. And luckily, there was only one application which has been registered to this one because this is a custom intent. But what happens if you're sending out an intent where many applications has been registered to? And let's find this out. So what we can do is we can do the following. Okay, so we are using once again our activity manager, and now we are sending out an intent which is used by many applications, which could be, for example, an action, Android intent action view. So this is a common action for an intent, okay? And we can also apply a category, this one over here. So there are many applications which has been registered to this event. So let's put out or pull the smartphone in the let's put the smartphone in the foreground and let's see what happens if we are triggering this. I'm executing this in 3, 2, 1. And oh, interesting. So here we can see we've got one application, intent sniffing, which might have been used before, but also all these other applications has been registered to this event. So these are now all applications which has been registered, and all of them are telling the smartphone, hey, your request, I can handle this. And the user has now the choice to open the application. So it's about the user to make the decision which one should react to this event. For example, this calendar. Then the calendar app will be opened or will react to this event, and all others are simply just ignoring it. Okay? So that's the concept behind an implicit intent, sending out an event without knowing which application is going to open it. The other one is the explicit intent, and this is something we have seen over here. So let's see this one. So here we are defining the exact package name which should serve this event. And this is something we cannot sniff. So if we are calling an explicit intent, if we tell this application this change pin activity to open it, we can of course also provide some data. But this is an information that cannot be sniffed by another application. Regarding to implicit intents, like this one, this is a different story. Okay? So if the user misclicks, then the attacker will have the information. Alrighty? Okay. If you have any questions regarding to this one, please drop me a message in the comment section, and otherwise I'm looking forward to see you in the next part.